All right, guys, I'm not here today. I'm at the regional golf meet. I'll be back on Wednesday where we will cover our test that we just took and get that rolling. And if anybody needs to retest, we'll take care of that process, start that process on Wednesday. But today, get us rolling here, we're going to look at reflections, lines of symmetry. We're also going to look at translations and rotations. So we're going to really see geometry in motion and how patterns occur when we move things, whether it's through a reflection or just a translation or a rotation. So we're going to take the time today to look at geometry in motion. First off, we're going to look at a reflection, okay? And just like you reflect your image off of a mirror, we're going to treat the x-axis as our mirror, and we're going to reflect across. So everything that's here on this x-axis above it is going to be reflected below it. So what we're going to do first is we're going to look at what are the points here. A, that's at 1, 2, -3, and then up 1, 2, 3, 4. So that's positive 4. B, positive 1, 2, 3, 4, up 2, so positive 2. And then C would be at 1, 2, 3, and then up 1, 2, 3, 4, 5, 6, 7. Now, hopefully you could all do that without my help. Okay, but now we're going to reflect this image across the x-axis. So that just means that this A, which is 1, 2, 3, 4 units above the x-axis, is going to reflect to 4 units below the x-axis. 1, 2, 3, 4. And that is A prime, and the prime just means it's a new A. That's the second image. And then we'll do that for all 3 of these. B, since it's across the x-axis, it's 2 above, so it would be 2 below. C is going to be 7 above, so it would reflect down 1, 2, 3, 4, 5, 6, 7 below. There is no side shift. We're reflecting straight across the x-axis. Now we can connect these dots. And we have a mirror image of the shape that's above the x-axis. If we folded the paper along the x-axis, these 2 images would lie right on top of each other. Now, we have new coordinates. We need to go and place each coordinate into the appropriate spot. So A now is going to be at -3, -4. B, the 4 stays the same. We reflect down to -2. And then the C, if we count it out, it is going to be 3 to the right, 7 down. So that's 3 and -7. Now, when you look at this and you look at these results, do you see a pattern for each one of these? Whatever our X and our Y value began with, like -3 and 4, after the reflection across the X-axis, the X value stayed the same, but the Y value changed. That's going to be the pattern that we see. So we can actually, without physically doing the reflection, we could just do the pattern, put those in, and then go back and plug these in. All right, that was across the x-axis. Now we're going to look at it across the y-axis. So here's our y-axis. Our original points here, x is at 2, 1, 2, 3, 4. Y is at 1, 2, 3, 4, 5, 6, and up 2. So 6, 2. Z is over 2, but then down 1, 2, 3, 4, 5. So that's -5. And we're going to reflect this across the y-axis. So that means if the x is 2 to the right, 1, 2, I'm going to be 1, 2. My new x prime, is going to be right there. My y is 6 units away from the y-axis. So then I need to go 6 units in the opposite direction. 1, 2, 3, 4, 5, 6. Now my z, 1, 2 away from the y-axis, 1, 2. Now we have a mirror reflection across the y-axis. How did our pattern happen here? Well, my height didn't change on the 4. My y value stayed 4, but my x value went to -2. The new y is going to be -6 up 2. And z is going to be -2 and down 5. Now, think about the pattern that we get from this. When we're going about the y-axis, whatever our original x and our original y was, the x value changed signs. The y values stayed the same. So whatever our x value was, it went from positive to negative, and it would also work the other way. If this would have been negative, it would flip to positive. Our last line of reflection that we take a look at is going to be the line y equals x. And it's this line that goes diagonally across the coordinate plane. Now what's interesting about this is going to be like a reflection, and then it bends it. It's not going to be a direct reflection right across. So for instance, the s, as I count to that line, s is 1, 2, 3. Then it's going to reflect it down 1, 2, 3. And there's my new s. So for my t, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's my t prime. R, I got a long way to go all the way over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I got to reflect down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there is my reflection of this shape along that line, y equals x. Okay, once again, it's not a direct straight across reflection. Because of this slant here, it's going to be, if it goes to the right, it hits that line and reflects it down. Okay, so all of these, we counted to the right till we got to that line, and it reflected it down. The r was the same way, 10, and then reflected it down. Now let's look at how the coordinates changed. Let's start with r. R is at 1, 2, 3, 4. That's -4 because we went to the left. And then up 1, 2, 3, 4, 5, 6, +6. The new r is to the right 6, and then down 4, so -4. Look what happened there. So now s, -1, +2. S goes from here, to the right 2, and then down 1. You see a pattern happening. Let's test it one more time with the t. The original t would have been at 1, 2, 3, 4, 5, 6 units to the left. So -6, 1 unit down. And then now t is going to be 1 unit to the left and 6 units down. Now notice that as we look at our pattern that all of our numbers here, they stayed the same. The signs didn't change, okay, but they flipped. So when we reflect across the line y equals x, whatever our values for x and y originally were, after the reflection, they flip. Okay, on this back side of the page, we're going to look at lines of symmetry. Now, symmetry, you can think of them like semesters. We split up the school year exactly into 2 halves. So, whatever lines of symmetry are, they are lines that will cut figures exactly in half, kind of like a bisector, okay? But there can be multiples. Sometimes there is no lines of symmetry, sometimes there's exactly one, sometimes there's exactly two, and depending on the shape, can determine how many lines of symmetry we have. Okay, we're going to come back to example 4. We're going to look at example 5 right here. And several different examples that we see is if you take a face and you have a line of symmetry that goes right down the middle there. That's one line of symmetry. We can't do a line of symmetry here because as we fold this over, the eyes would line up on the mouth. It's not an identical fold that happens. So on this one, there's exactly one line of symmetry. Now you can go through these and try to figure out for yourself which ones have lines of symmetry. Is there exactly one? Is there multiples? So go ahead, take the time and do that. We're going to pause the video for a second and let you think about this on your own. Okay, hopefully we're stopping the video, we're paused, but now we're back in action. You have your guesses on here, or maybe they're correct and they're not guesses and you understand what's going on. Okay, but for B, which is a hexagon, there's 6 sides here, we can get an easy line of symmetry, 1, 2, where we can fold that exactly in half. But then we also have lines of symmetry when we come through each one of these sides. So there's another one. There's another one. And if I go from corner to corner, we have more lines of symmetry. So for this, 1, 2, 3, 4, 5, 6, and then that's the same one. So there are 6 lines of symmetry on that hexagon. Okay, C is very interesting. We got 2 circles here, donut, however you want to look at this. Okay, we obviously have where we can fold it right down the middle that way. We can fold it down the middle this way. But then we also get to where we can fold it multiple different ways over and over and over again. So on this one, we can come up with as many possible lines of symmetry as imaginable. So what we'll say here is an infinity lines of symmetry. There's an infinite amount of lines that we could put and make symmetrical lines. The rectangle, just like your sheet of paper, how many ways can you fold it and all the lines match up? Well, you can fold it hamburger style, and then you can fold it hot dog style, but you can't fold it diagonally because the corners won't match up. There's only 2 lines of symmetry here. All right, for most of the years that I have people on this, they always get 1, 2. But on this one, you actually do have another line of symmetry here and here. So that's 1, 2, 3, 4 lines of symmetry. And then the last one here that we have is this lightning bolt. And there is no way for us to do a line of symmetry through this. Even if we try to go right down the middle there, there is no lines of symmetry. So we just put no solution symbol on that. Lines of symmetry, they have to cut the shape exactly in half. So back up to problem number 4 here. If we look at examples 1, 2, and 3, we're looking for the lines of symmetry off of those examples. So example 1, where I have these 2 shapes. The lines of symmetry would be here, the x-axis. On example 2, the y-axis. In example 3, that line, y equals x. Those are our lines of symmetry. So on the back side here, example 1, x-axis. Example 2, y-axis. And example 3, the line y equals x.